problem 16. So we read it and it says 110 sixth semester students were interviewed, 28 took business, 31 took nutrition, and 42 took philosophy. So also 9 took business, more specifically, and nutrition. Then 10 took business and philosophy, and 6 took nutrition and philosophy. 4 were found to take all 3 subjects. So we need to build a Venn diagram that models the situation and answer the following, which will be these other problems that we'll see later. So first, we draw the Venn diagram. In this case, there are 3 subjects, so we have to draw 3 circles that represent each subject. So first we draw this circle that will represent the subject of nutrition. Then another one here. This one is for philosophy. And the third one is for business. So you will need to intersect here. And here you write business. And don't forget to always box your Venn diagram. So here we box it. And we read it once more to understand. So the total here inside the Venn diagram must be 110. So if we add 20 to 28, these are the 3 important things that matter in order to answer the Venn diagram. To know that there are 28 who took business, meaning that this whole circle, there must be, here the sum of these 4 parts will be 28. And then for nutrition is all this 31. And for philosophy, all this is 42. So we know, it tells us 9 took business and nutrition. So between business and nutrition, here is a 9. So I'll make it clear with another mark here. Here it must be 9. Okay, so we already answered this one. Now 10 took business and philosophy. Here between business and philosophy, here must go the number 10. Then 6 took nutrition and philosophy. So here between nutrition and philosophy, there must be a 6. And we also know that there are 4 students who were found to take all 3 subjects. So here in the middle, there must be a 4. And remember, with these 3 numbers, we can already find how much is in this section of the students who only took nutrition. Remember that the total for nutrition of students who took nutrition is right here. 31 took nutrition. So you add here 6, 4, and 9, and you subtract 31 minus the sum of these 3 numbers, which will give you 12. Now here you can also answer philosophy. Same here, you add these 3 numbers, which is 20. So we're gonna subtract the total of philosophy, 42 minus 20. So it's gonna be 22. And here we know also that with these 3 numbers, same. You subtract the total of business, which is 28 minus these 3 numbers, which will give you to 5. Okay? And we are not done yet because we are missing, the total must be 110. And if we sum the 3 subjects, 28 plus 31 and plus 42, it's gonna miss, you're gonna miss 9 more students, which will be the students that don't carry any of these 3 subjects. So there are 9 students who don't have business, neither nutrition nor philosophy.
Okay, so for 16.2, next it says, we randomly choose a 6th semester student. What is the probability that student? So for problem A, it says, for the student that took none of the 3 subjects, okay? So a student who is not for nutrition, neither philosophy nor business. Here we have 9, which is 9 out of the total, which is 110. Okay, so for part B, it tells us that the students who took business, yet not nutrition or philosophy. So we are not going to count any of these 3 in the circle. We are just going to count the 5 that are the students, the only ones who are carrying business. So you write the probability of the students who only have business, okay? So the students who only carry business are going to be 5 out of the total one, which is 110. and you can simplify your answer, which will be 1 over 22. So you write P of nothing, which are the students who are not in any of the three, is equals to 9 over 110, okay?
Okay, now for letter C, we'll look for students that took philosophy and business, no nutrition. So it will be basically the intersection of philosophy and business, which will be 10. So it will be P
Of business. And intersection of philosophy.
being 10 over 110. Later simplified as 11 over 1 over 11.
Nali?
Now for letter D, students who took business or nutrition, which will be the sum of 12, 9, and 5. So it will be P of business, B, union, nutrition, N. It will be the sum of those three values, B, 26 over 110, later to be simplified as 13 over 55. Okay, now for letter E, we're looking for at least one student that took any of the three subjects. So basically the opposite of the 9, which would be the probability of nothing complementary, which will be 101 over 110. Okay, now for letter F. We're looking for students who took at least 2 classes out of always 3. So we're gonna focus on the middle values. So basically 6, 4, 9, 10. Because they took at least 2 out of the 3, and we'll sum them up, being, so it will be the probability of greater than or equal to 2 classes. So it will be the sum of these 4 values, 29 over 110. But the 6, 9, and 10 are only people who are focused on 2 classes. So we'll add 6, 9, and 10. So it would be probability of equal to 2 classes being the sum of 6, 9, and 10, 25 over 110, being simplified to 5 over 22. Okay, so now we'll focus on these 2. So to make it cleaner. So letter G. Students who took only 2 courses. So we'll focus on the middle values, but the 4. Since the 4, you can count it in any of the 3 classes. Now for letter H. And it asks us, students who took 1 course only. Okay, so look at a chart and focus ourselves on students who only focus themselves on 1 class. So it would be the 12, 22, and 5. So basically add them up in the probability of equal to 1 class. And it would be the sum of 12, 22, and 5, 39 over 110.
36. A password consists of 3 different letters where each letter is used only once. How many different possible combinations exist? This is a problem either of permutation or of combination. The first thing we know is that we have 3 different spaces to fill out. So our R is going to be 3. And there are letters. So the letters of the alphabet are 26. So our N is going to be equal to 26. Now, this is a clear example of a permutation, because if you change the letters of the password, if you change them of order, then the password will be completely different. So in this case, the order does matter, so this is a permutation. So now that we find out that this is a permutation, we have to find out if repetition is allowed or repetition is not allowed. In the problem it says where each letter is used only once, so there is no repetition allowed. And because of this information, we're going to use the formula of NPR to get the final result. Now we just substitute the values into the formula, which are 26 letters, the P of permutation, and the 3 spaces we have to choose from. We grab the calculator and we get the final answer of 15,600 different passwords.